bars. We're going to start with the widths of them. What's the width of the first one? A. 4 from 1 to 5, right? So that's 4. The next one?
1.
Next?
3.
Yeah. The next? Yeah.
4.
Lovely. Okay. Now we go through and we say, hey, we're using a right Riemann sum. Okay. So for A, should it be f of 1 or f of 5? F of 5 because it's on the right, right? You guys are in AP calculus. I think you got your rights and lefts, right? That's how you guys know that one, right? You hold your fingers up like that? This is an L, so you know right to left. Okay. All right. Shh, shh, shh. So this is where it can get really tricky, and I guarantee somebody made this mistake in the room already. You could write just 5 here instead of f of 5. That's one common mistake, right? You could come up here and say, oh, all right, f of 5, like, and then just put 5 over there because you're stupid. Okay, but you're not stupid. You're just making stupid mistakes. Trying to backpedal there real quick. Okay, I know, it's like I'm going to put on the internet for everybody. Forgive me, parents, for calling your kids stupid. What is f of 5?
7.
Right, when x is 5, f of x is 7. So f of 5 is 7. So this is going to be 7, this is going to be what?
12.
And f of 9 is,
5.
and so on. Yeah.
So for a test, do we have to write all of that out?
No, if you have developed your own shortcuts, that's fine. I would write stuff, I would write something out, Mr. McCormick, so that when you're on the test, I can give you partial credit, or Ms. Sparks can give you partial credit if you like just made one small math error. If you just have like a bunch of meaningless stuff that nobody else can follow, and you screw up one thing, then I can't give you any partial credit for that.
I just like write out the numbers like 7 times 4 plus 12.
Yeah, I think that's fine. I think that's fine. Okay, questions? Raise your hand if you've gotten everyone right so far. Nice. All right, well, we got one more, right? What's that? It's all easy. That's it. Shh. There's nothing in here beyond algebra 1, right? It's just like multiplying numbers and remembering little, like, do things on the right and to not screw up the adding things together and stuff. All right, we got one more. Shh, guys. Shh, quiet. The answer was 73. Is that right? Is that what people got?
Yes,
sir. Because I'm prone to mistakes myself. Okay, let's use a left Riemann sum to approximate the area under the function tabulated below from 3 to 11 with n equals 4. So this is a little bit confusing. Yeah, tabulated means put in a table. This is tricky, right? And I did this on purpose. Okay, sometimes they'll give you a table for this kind of stuff, which is fine, okay? And sometimes the table will indicate to you which subintervals they want you to use, but it could specify, I want from 3 to 11, and I want n to equal 4. And so what's confusing is I have all this information, I have 1 and 2, and I've got 11 and 12, right? Do I need that?
No.
No, right? And so they might give you all kinds of stuff and say like, oh, I don't need that, that's fine. Okay,
You need
but,
11, right?
what's that?
Don't you need 11?
Yeah, you need
This is a left Riemann sum, so you actually don't.
You don't. Yeah.
Yeah, but to find out the spacing, don't you need it?
Yeah.
No, well, you need to know that you're going to 11,
Yeah.
but you don't need to know what the function's value is at 11. Okay, so it's a left Riemann sum. We're going from 3 to 11. We're splitting it up into 4 parts. Just a reminder how to mathematically calculate how wide each bar should be. You can use this little formula which I gave, right? Which basically says you take 11 minus 3 and divide it by the number of things you want to split it into, right? If you know you're going from 3 to 11, then you just find the distance between them, which is 11 minus 3. Okay, that's 8. Okay? And if you want to split that into 4 equal parts, then 8 divided by 4 is 2. So the width of each thing is 2. If you go through this process and you get something like, oh, it's supposed to be 7/4, that's an indication to you that you probably made a mistake, right? And only on the AP exam would they be so equal. Does that make sense, guys? What I just did there? If you can do that in your head and intuit that, that's fine. But if you need a little help to calculate the width of each bar, that's a good formula. Okay. Shh. No. Yo.
73.
She is.
Yeah,
Okay. Good. I'm glad to get rid of her. Okay. Yeah.
Read it, you go.
All right. Shh. Okay. So our first interval is from 3 to what then? If we know each interval is too wide.
3 to 5.
3 to 5. The next one.
7.
Yeah, and so on, right?
Someone work on the blog.
Yeah, I'm going to put this all up.
say? No.
Okay. What did you just say?
Okay.
Yeah. Right. Shh, guys, let's refocus. Okay, we got to find the area of all four of these bars, A, B, C, and D. Each one is how wide again? 2. Liv, you have a question? Yeah, hustle. All right. Is this a left Riemann sum? Shh. Seriously, it's annoying. This is a left Riemann sum, so I should be using the function value on the left side. So for A, what am I doing? F of what?
F of 7. 3, which is 7.
Right. So that's what I'm saying. So Eniola just made what I'm now going to refer to as the Eniola mistake. You may not have actually done it on the piece of paper, but it's something that could happen, right? You might say, all right, I need f of 3, and then come up here and see the 7 there, and then like somehow write f of 7 here. You see what I mean? Okay? You just have to be really slow and methodical to make sure that, okay, I'm talking about the function's value at 3, which is f of 3, which is 7, okay, and not me giving you the middle finger in the middle of the class. But f of 3, it's just easy to get confused. There's a 7 here. Just like take your time and be careful.
So is it f of 3?
Yeah, f of 3 for the left side, right? F of 5 for that one, 7, and 9, okay? And again, like Wally said, your instinct might be to go to f of 11 because you know it's from 3 to 11, but because this is a left Riemann sum, you never get to the farthest right. And if it was a right Riemann sum, you don't start at the farthest left.
Yes, sir.
Okay.
Yeah, I get it.
Okay. What's next? F of 3 is what?
7.
Times 2.
14.
F of 5
1.
times 2.
2.
All right. F of 7
-6.
times 2.
-12.
Is that okay? Can we have negatives?
Yes.
That's fine. You just treat it as it's negative. It's all good. F of 9 is 0. 2 times 0, of course, 0. Add them up.
0. You get 4. Yes.
Who got the whole sheet right?
Me.
Whatever. I'm not impressed. Yes, Livy.
So, why do you have to start the Riemann sum at 0? Like, why does it always start at 0? Like, for the y? Like, why do you, like, draw the thing from 0?
I mean, why does it go from the x-axis up? So that's so a Riemann sum is for finding the area. Shh, guys, this is important actually. It's for it's about finding the area between a function and the x-axis. Okay, so it's about finding this. That's just what it is. It's finding the area here. Okay, and it's finding the area here.
I thought it was, like, finding it below. It's just, like, finding
No, so below there's an infinite amount of area because this goes down forever. Okay, so when I say below, that's kind of a cheesy term, especially when you're under, so it's actually above. So it's really the area between the function and the x-axis.
Oh, okay.
That's an easier way to think of it.
That's better.
Okay, let's rock the do now, then we'll do middle and trapezoidal, and we'll get out of this mess.
Rock the do now.
Okay, shh. That's right. I'm not here for the second half, thank goodness.
No.
Miss Barmore is coming.
Who is that?
You're gonna work.
Far more than math.
Are we gonna get more?
All right, shh, quiet. So, the do now was to use a right Riemann sum to approximate the area, that should say, not the r, under y equals sine x. And if you want to say it better, the area between sine x and the x-axis, from 0 to pi with 4 subintervals. Okay, that's the graph of y equals sine of x. Did you know that?
Yes.
You need to know what the graphs look like. You need to know your special angles, okay? The unit circle, that is. You need to know, excuse me, what the graph of sine looks like versus the graph of cosine, which starts where? 1 and does the same short stuff. Turn that camera off. Okay. This thing says we're going from 0 to pi. So we're looking for this area, right? Which one of you astute young scholars can tell me what the Riemann, a perfect Riemann sum? Let's say forget about Riemann sums. What if I was to find the area between sine and the x-axis from 0 to pi? What would the answer be? No. What'd you say?
A circle.
What'd you say?
Cosine.
What'd you say?
1. It'll be negative cosine.
Sorry, let's ask the same question. If I am asking for the area between sine and the x-axis from 0 to pi,
It'll be 0.
Agree or disagree?
0.
0 is right. All the positive area here and all the negative area here would cancel out because it's the same shape, and you'd end up with 0.
It's a circle.
Area is a number. The answer is 0. Okay. Anyway, unfortunately for you, you were not asked to find the area from 0 to 2 pi. You were asked to find the area from 0 to pi, so you actually have to find the answer out. And we're asked to split that into 4 subintervals. I saw a lot of people go into decimals. But if you want to split pi into 4 subintervals, then each subinterval is a quarter pi, or pi over 4. Does that make sense?
Yeah.
So you should be able to do that and not rock decimals.
What is a quarter
What if you like decimals better?
Pi over 4, or a quarter of pi.
What if you like decimals better?
Good luck on the test.
Why you can't use decimals on the test?
You don't get your calculator for half the test.
Oh, for real?
For reals. Okay, shh. Now, we have bars that go from 0 to pi over 4, from 0 to pi over 2, from 3 to pi over 4, and then to pi. Now, before I draw this bar, I want people to think about it. The right Riemann sum gets the height of its bar from the right side of the subinterval. What's the function's value on the right side of this last subinterval?
0.
So how high is my bar?
0.
Right, so this bar actually doesn't even exist. I drew it as like thin as I could, okay, but it should actually be no thinness, right? It should be, or 100% thinness. It should be, there's no bar there because its height is 0. Okay. So the picture is not that important, but it's nice to know what the heck we're doing, right? So a function, the bar's height, right? For example, A is height. A is not as good as B. B's height is gotten from the function's value on the right side of its thing. So here's pi over 2, the right side, okay? And that's why it's as high as the function is there, right? Same thing is true for this one. On the right side, the function and the bar meet here at the right. On the right side of this, the function is 0, and hence the bar's height is 0. So there's no bar there at all. Does that make sense, folks? A little bit tricky. A little bit tricky. Okay, so again, these same 4 subintervals. Pi over 4 is 0.79. So if you did 0.79, this one would be 0.156. No, that's if you used 8. You don't know how to round. So it's 0.58.
No.
And 0.2. What's that?
3.16.
Right, whatever. Okay, so with 3.14, right? Because it's pi. She doesn't even know I'm talking about it. All right. Yeah. All right, so base times height for each of these. We got 4 bars again. Let's talk about the widths. What's the width of each one?
2.
No. Pi over 4. What do you mean 2? 2 what?
0.79.
Yeah, 0.79, right? They're each pi over 4 wide, because we took the big pi and we split it up into 4 subintervals. Pi over 4 for each of them. Okay, what's the height of each? This is a right Riemann sum, so we use the function's value on the right side of each of them. The right side of A is f of what? Pi over 4. F of pi over 2, f of 3 pi over 4, and f of pi. And again, since this is a right Riemann sum, we end at the right side of the interval, and we skip the beginning. Right? There's no f of 0. Okay? You put that in your calculator. F of pi over 4 is sine of pi over 4. Who knows what sine of pi over 4 is? Thank you. Who knows what sine of pi over 2 is? Sine of 90 degrees? 1. What about sine of 3 pi over 4? Root 2 over 2. And sine of pi? Right. Add them up, add them up, add them up, and you get 1.896.
What if you use 7.78?
Yeah,
You got it. If you use 0.78 or 0.79, you might have got something close, but this is right.
I got 1.74.
Well, that's what I'm saying.
0.42.
That's not right. You may have forgotten to multiply by pi over 4. All right. What's that?
Is it okay if you didn't convert this to this?
Absolutely, that's totally fine. You have root 2 over 2 plus root 2 over